Okay, this problem is 211 design, add and search data structure. So this is a problem of using try. To solve this problem, let's make a class try, and it has children instance variable and of 26. So let's first make it empty. It also has a flag, and we make it empty too. Okay, so for this, and we make a initializer function try, but we set it as empty as well. Okay, then we should make a node, a try node. So in the initializing function, we let root equals new try. Okay, so for adding words, let's first get the node as the root node. Then we go through each character in the word, and we check if the node has this children of this character. If it is null, then we create a new try node. Then we update the node to be this children node. Okay, at the end of the word, we want to set the flag as true. And for searching the word, first, if we want to first take the root node, then we use a helper function called find, and we pass the node root and also the index. We search starting from index 0. So this will be a Boolean helper function. So we pass the node and we pass the index, and if the node is null, then we return a false. If index is at the end of the word, then we want to check if the isWord flag is true or not. And because we need the word size, so we want to pass the word as another parameter. Okay, now we can go through, now we can search the actual character. If the character is a point, this is actually this is actually one of the difficulties of this problem. This is where it's the most difficult of this question. If it's a dot character, then we want to search each of this node's children, and we want to find out if the find can return true, then we're going to return true. Else, this is not a dot function, it's not a dot character, then we get the next as its children corresponding to this character. This character is word dx minus 8. Okay, and we're going to return passing this to the find function. Okay, if after all these iterations or searching, in the end we're going to return false, because if it doesn't return true here, and so it's going to return false. Okay, so let's quickly check if the code is correct. Okay, so here we want to make this public, so it can be, the methods can be used. So we made a children, make it empty. Its word is false by default. Make a initializing function, define a root, and in the initializing method we set as just a new try node. When we add the word, we take the node and check if for each character if it has a children corresponding to this this character. If not, we make a new try. Then we update the node. At the end of the word, we set the flag as true. When we do search, again we take the node and run a helper function. In the helper function, special case, when the node is null, of course it's false. Then if it's reaching the end of the word, we want to check if its word is equal to true or not. If the character is a dot, we want to search each of the node's children, and if one of them can return true, then we say it's true. And then if it's not a dot product, we get the next get the child node and also runs this recursion function, and at the end return false. Okay, let's submit. Test case is correct, and submit. Okay.